All right, good day. So in this video, we're going to be continuing with Euclidean geometry exam questions. And to be specific, these questions are from your November 2022 question paper, right? So now A, B, C, D, and E, they lie on the circumference of the circle with center O. Now remember, what is your cyclic quad? Cyclic quad is your four-sided shape in which its points are on the circumference of the circle. Now, but then we're going to get to that. Now they're telling us that AC is perpendicular to OB, right? Now, what is this line AC? Let me try and highlight it here so that you could see the line they're talking about. This is our line AC. And what do we call this line? This is a chord, right? And this is perpendicular to OB. Now, a line from center to the circumference, which is your OB, this would represent your radius, right? And remember, your chord is perpendicular to your radius. Now, this relates to theorem 1. It simply means that if your chord is perpendicular to your radius, this would bisect your chord into two equal halves in accordance to the converse of theorem 1, basically, right? So here, as a result, I can conclude that FC is equals to FA. Reason being is because my chord CA is perpendicular to my radii, which is OB, right? So these would be equal. Now, A1 is equals to 38 degrees. So let me highlight it here. So this is my A1. This is 38 degrees. Now, I need to determine my angle C1, right? Now, how would I go about finding C1? First, I like to draw out the shape, right, where my C1 is at. So here it's my center O. This is AE. Now remember this line that passes through your center and it cuts your circle into two equal halves. It's your diameter. So AE is my diameter, right? And as a result, this AE, it subtends or it creates this angle C. To be specific, my angle C1. And remember, angles created or subtended by your diameter, they are perpendicular. So here, my C1, right? So let me write this here. C1, it is equals to 90 degrees. Reason, this is an angle in a semicircle. Right? Your theorem 3, semicircle, right? So this here, it's 90 degrees. Now, we need to find angle D, right? So let me see where's my D. So let me highlight the shape my D is at. So, okay, I can't make use of this triangle CDE because I don't have any values for that triangle. So I can't use basically anything in that triangle to find D. So to identify another shape, let me highlight it so that you could see it. Right, so this is the other shape. Now, can you see that this is a cyclic quad because it's a four-sided shape CD, DE, EA, as well as AC. It's a four-sided shape and its points are on the circumference of a circle, right? So I'm going to first start by mentioning that. So I'm going to name where I'll be doing my workings. So cyclic quad. So I'm going to name that, okay, A, C, D, E, right? Which is my cyclic quad. This is the other shape. And why am I using this shape? It's because I have values in this shape. I'm given A1. I have this angle C alone, right, which is 90 degrees. Now, what is that angle that I'm trying to determine here? I'm trying to determine this angle here, D. Now, can you see that this angle D is opposite to my angle A1? And what do we know about opposite angles of a cyclic quad? They are supplementary, right? So here I'm going to say angle D plus A1. This is 180. And why is this? These are opposite angles of a cyclic quad. Now, in this instance, we are not told that this is a cyclic quad, but because we know what exactly is a cyclic quad, hence we are using the properties of a cyclic quad to answer this question, right? So here, opposite angles of a cyclic quad, they are supplementary, right? And now my angle D, which is what I'm trying to solve for, my A1, which is 38 degrees, and this is equals to 180. So as a result, my D, it will be 180 minus 38. And punching that into my calculator, my angle D, it will be equals to 142 degrees. Right, so let me write that there. So D is 142 degrees. All right, now I found my angle D. Remember to show these workings on your answer sheet. So now I need to try and determine the angle ABC, basically my angle B. So let me try and highlight that angle. So let me first remove these highlights that I've made before with the green highlighter. Now, this is my angle Let me highlight the shape that it's at. Right, so this is the angle that I'm trying to determine, this angle right over here, right? And how would I go about determining this angle right over here, right? Angle B. Now, I want you to note something again, right? So can I use this triangle ABC? Not really, because why? I don't have any values inside this triangle that I could use, right? So I won't use this triangle. What other shape? So first step, try to identify the shape that your angle is at. And then after identify the shape, try to use the properties of that shape to solve for whatever angle you're looking for. So in this case, I'm not going to choose the triangle because I don't have enough information on my triangle ABC to solve for B1 and B2, which is my whole of angle B. So what other shape is my angle B is at? So I can see that I have B, C, E, A, which are on the circumference of the circle. So as a result, this would be a cyclic quad. So let me highlight the cyclic quad I'm talking about. So can you see it highlighted in yellow? Okay, it may not be visible. So, but then I've tried to highlight it there. So now, remember, I'm trying to look for my angle B, right? So first, okay, let me highlight these on the side. Or let me try and erase here. All right, so I'm going to name my cyclic quad. So B, C, E, A, cyclic quad. All right, so remember, your opposite angles of a quad, right? So if I could find E1, can you agree that if I take E1 and I add it to angle B, right, they must be equals to 180. Why is that opposite angles of a cyclic quad? Now, if I could find E1, this would enable me to find this angle B. Now, how would I find E1? Making use of what I've calculated before, right? So I know that this angle C here, so let me try and draw the triangle here. So this is C, this is E, E1, and this is angle A1, right? Now, I know that this angle here is 90 degrees, and I am given this angle right over here, A1 is 38. So can I find C1? Yes, I can, right? So here, to find E1, I would say, okay, if I take angle C1 plus angle A1 plus angle E1, I expect to get 180. Why is that? This is sum of angles in a triangle, right? Sum of angles in a triangle. Now, let me name my triangle in triangle. So this is triangle CAE, right? So in triangle CAE, now my C1 is equals to 90. My A1 I was given as 38, and I'm looking for my E1. So as a result, my angle E1 would be equals to, so 90 plus 38, it would be equals to 128. Now 180 minus 128, it would be equals to my angle E1, which would be equals to 52. So I know that this angle right over here, E1, it's 52 degrees. And remember, I said if I could take my E1 and add it to my angle B as a whole, right? So E1, which is that, and adding it to angle B as a whole, this should be 180. Why is this? These are opposite angles of a cyclic quad. And now I can solve for the whole of angle B, right? So let me go about doing that. So as a result, I know my E1, I've calculated it as 52, plus my angle B, which is what I'm looking for. This is equals to 180. So as a result, my angle B to be equals to 180 minus 52, and this would be equals to 128, right? So the whole of angle B is equals to 128. So let me try and write it here. Right. So this is 128. Right. Yeah, I feel like that's better. Let me just erase here. All right. Now let's see what the other question is requiring from us. So now they're giving us length. So if AC is 8 centimeters, so let me go and write that there. AC. So let me first try and remove these highlighted lines. Now, so okay, let me try and, and separate the triangle they're talking about, right? Or like basically those lines that I'm given the length of. So So they're telling me that our AC I was given as 8 centimeters. So the whole of AC is 8 centimeters. And now remember your AC, right? So here I have F, right? So this is the point that I need to mention most importantly. Remember before when we started, I said your AF, it will be equals to your FC, right? And why is that? Our chord is perpendicular to our radius, right? So this is basically the converse of theorem 1. Our chord AC in this instance, it's perpendicular to our radii, and our radius that we're talking about is radii OB, or you could say, yeah, radii OB, right? So as a result, these two would be equal. Now, if that's the case, it simply means that the length from A to F, it will be 4 centimeters. The length from F to C, it will be 4 centimeters. Now, let's see what other information are we given. We're given BC as 5 centimeters. Now, let me try and draw my BC. So if I should start here, this is my B, and BC it's given as 5 centimeters. Let me confirm. Yes, now we need to determine the length of BF. So this length right over here. So let me draw my line BF. So we need to find this length, BF, right? Now, remember, this angle here, it's 90. As a result, this angle here, it will also be 90. Why? Because sum of angles in a straight line, they should be equals to 180. So to answer this question first, I would first start by mentioning this point that my AF is equals to FC. Reason being is because our chord is perpendicular to our radius, right? So let me just try and erase here at the bottom. Now, as a result, FC, it will be equals to 4 centimeters. Now, another point that I would need to mention is that this angle right over here, basically angle BFC, right? BFC, this is equals to 90 degrees. Why? Because we were given, so let me try and make an erase here. We were given this angle as 90. So as a result, this would also make this angle to be equals to 90, right? And our reason here is sum of angles on a straight line. Or, or you could say angles on a straight line, right? Basically, yeah, angles on a straight line. So I know that the angle here, it's 90 degrees. Now, this simply means that to find my BF, I can use my theorem of Pythagoras in this instance, because why? I have my right angle triangle. So first, I'm going to start by mentioning my right angle triangle that I have. So in triangle, so my triangle, it's BCF. So I'm going to use my theorem of Pythagoras, whereby I'm going to say r squared is equals to x squared plus y squared. Now remember your hypotenuse, which is your r, it is this line that is opposite to your angle of 90 degrees, right? So in this case, it's BC squared. And our x squared is going to be FC plus y squared, which is the line that we're looking for, BF. Right? So now substituting values, our BC, right? So let's make it in terms of BF because we're looking for BF. So as a result, BF squared, it will be equals to BC squared minus FC squared. Now, substituting values into this formula, our BF, or we're looking for the BF. Now our BC is 5. So this would be 5 squared minus FC, which is 4 squared, right? And this is equals to BF squared. And remember, because we're looking for BF, to get rid of the squared, we need to square root both sides. And punching this into your calculator, you should get the actual length of BF. Now, doing so, my BF, it will be equals to 3 units. So this line from BF is 3 units, or rather 3 centimeters, because here our unit is in terms of centimeters. This would be 3 centimeters, right? So also here, let me write centimeters. And this would be your final answer, right? And that'll be all for this question. In the next video, we're going to be still continuing with the Euclidean questions from this question paper. So make sure you stay tuned. Thank you.